All right, let's use this question to understand the effects of series connection and parallel connection in electrical network. So this question says a circuit has a resistance of 200 ohms. The resistance of the circuit can be reduced to 120 ohms. When so now the question is what they are looking for is what other type of resistor and in what type of connection are we going to connect it to this 200 ohm resistor so that the equivalent resistance will be 120 ohms. So in order to build better understanding, now there are two basic connections, electrical series and parallel. So for the series, first resistor, second resistor, R2. You know, for series connection, the equivalent resistance here can be given by what? R1 plus R2. So you check if we want the total resistance or the equivalent resistance to be as R equivalent to be 120 ohms. And then one of these resistors is 200 ohms. You see, is there any number that you can add here to make this 120? What value of resistance are you going to add here? Of course, there is no value of resistance you're going to add there unless you are talking of a value like minus 80 ohms. There is no resistor rating that is negative, that is a negative number. No, the resistor doesn't have negative. There is no way you go to market or say resistor device right there. This thing is negative 80. So that means series connection cannot hold because in series connection the equivalent resistance, the resistance will add up. It won't be reduced. But however, in parallel connection, you have resistor 1 and resistor 2. Parallel connection. Now the first one here is 200 ohms. So here R2, we don't know what it will be. But if we measure the equivalent resistance between this point A and B, we want the equivalent resistance R equivalent to be what? 120 ohms. Now you know that in parallel connection, the equivalent resistance will always be less than the smallest value of the resistor in the network. Take for instance, if this R2 was 50 ohms, that means the equivalent resistance of this parallel connection will be a value less than 50. So what am I saying? I'm saying that in parallel connection, when you connect resistor in parallel, you are reducing the equivalent resistance. It is not adding up, as you are reducing it. I wouldn't use the word subtraction because some people may take that word literally, subtract and into subtraction. No, in parallel connection, we don't do subtraction. We do 1 over R equivalent. 1 over R equivalent equals to 1 over R1, 1 over R2, and so forth. So the more resistors we pile up in parallel, it uses equivalent resistance. So now, how are we going? So what value of, you have seen now, I've established that it's a parallel connection that will help to reduce the equivalent resistance to 120 ohms, not a series connection. So having established that, I'll then find that resistance. So we know that for two resistors connected in parallel, R equivalent given as what? R1 times R2. I'll say R1 times R2 divided by R1 plus R2. Now we know our equivalence. If you substitute your value, the resistor, it's 120 ohms. That's we want something that will give us the effect of 120 ohms equals to, and we know one of our resistors is 200 ohms. 200 times what? R2. divided by 200 plus R2. So we have established an equation that will help us find that resistor, define the value of that resistor that will reduce the equivalent resistance to 120. So which is R2. So what is left is now to solve this equation. So as usual, 1 0 here will cancel one of the zeros here. And then you can still cancel more. 4 will cancel 12 3 times. And 4 will cancel 20 5 times. So we now have 3 equals to 5R2 over 200 plus R2 over 200 plus R2. So if you do cross multiplication there, you'll be having 3 times what? 200 plus R2 equals to 5R2. It's not an amount that you must cancel the y. You can first do cross multiplication, but in the end, this will cancel that. If I first did the cross multiplication, one in this place of 3 would have been 120, and here would have been 200, which can still cancel. So we're on track. So we expand this. 3 times 200 is 600. 600 plus 3 times R2 is 3R2 equals to 5R2. So we collect like terms. 3R2 will go to the right so that to operate with this 5R2 because they are like terms. 600 will remain. So 600 equals to 5R2 minus 3R2. So that's 600 equals to this minus this will be 2R2. So if you divide both sides by 2, your R2 will be equals to 600 divided by 2, give you 300 ohms. So if you connect a 300 ohm resistor in parallel to 200 ohm resistor, the equivalent resistance or the effective resistance will be what? The will be 120 ohms. So what is our answer there? What is our answer there? Our answer is option A. Thank you.